Alright, in this video we're going to actually solve using factoring. So we've factored already, let's solve using factoring now. But first, what we need to talk about is a couple things that really you need to know before we can do this. First thing, what is a solution? What does it mean to be a solution? Well, when we're solving these, what that means is we're finding where it crosses the x-axis. So when we're solving quadratics, we're finding the x-intercepts. We're finding the place where it crosses the x-axis. So really, we have three different ways that how many solutions a quadratic could have. And let's show you those three different ways. The first and probably most obvious way is that you look on here is that it has two solutions. It has a solution here and it has a solution here. So that has two solutions. It crosses the x-axis two times. The next way, there's probably the next most obvious, is that it has no solutions. It doesn't actually ever cross the x-axis. But really, there's not no solutions. There's no real solution. And the last way that a lot of people don't think about is that I have one real solution. So one solution. And it's really one real solution. And I should go back to the original one. It should say two real solutions, no real solutions, and one real solution. So really, that brings us to what it means to be a degree of a polynomial. So if I give you guys an equation like this, and I ask for the degree of that polynomial, what you need to look at is you need to look at all of the exponents, and you need to tell which one is the highest. Since 4 is the highest of this, that means that that is the degree of the polynomial. Now, they're not always going to be in order, so make sure you look for the highest degree, not necessarily which one comes first. So the fundamental theorem of algebra, what that tells you is what you have to look at is the degree of that polynomial, and that will tell you how many roots that polynomial has. So how many roots that polynomial has. And what roots are, that's another word for solution. That's another word for the zeros. How many times it crosses the x-axis. All right, so that leads us into what we're going to be talking about today, solving the quadratics. Solve this quadratic. Well, the question is, how do we solve it? First step is going to be to factor it. And I'm not going to show you guys how to do it. I'm going to pause real quick, let you guys try it if you want to, and I'll show you in 1 second how to solve. So again, I'm not going to focus on factoring in this video. There's another video out there to focus on factoring. But if you factor this, you should get x plus 9 times x minus 4 equals 0. Now really, how do we solve this? It's a great question. The way you solve it is using the zero product property. Now in words, what it means is if you have a product of two expressions is 0, then one of or both of the expressions equals 0. So again, what does that mean? That's kind of a little confusing. So let's go back to our first example there that we were just looking at with x plus 9 times x minus 4 equals 0. Well, what that means is that if I multiply anything by 0, it's going to equal 0, right? So what I'm going to do is I'm going to make each of these pieces equal 0. I'm going to start out by making x plus 9 equals 0. So that means that x equals negative 9. Now I want you to watch real quick what happens when I plug in negative 9 into that equation for x. So when I plug that in, that left side equals 0 times, well, this is going to be negative 13 equals 0. Well, does 0 times negative 13 equal 0? Well, yeah, 0 times anything equals 0. So it doesn't matter that the second side over here didn't equal 0. All that matters is we made that first piece equal 0, because anything times 0 is going to equal 0. So the same thing holds for our second solution. What we're going to do is we're going to take this piece down, and we're going to set x minus 4 equal to 0. Well, then x equals 4. So what that tells us is that we have two solutions, two real solutions for this problem. And the two real solutions are x equals negative 9 and x equals 4. Sorry, you say x or x equals 4. So these are or, because either one of these would work as solutions. All right, so let's go back to that page where we wrote down the zero product property, and let's solve this piece real quick. So again, to solve this quadratic x plus 1 times x minus 3, all we have to do is set x plus 1 equal to 0, and also set x minus 3 equal to 0. Well, that means that we have x equals negative 1 or x equals 3 are our two real solutions for this quadratic. All right, let's look quick at this one. These are already factored forms. Not all of these are going to be quadratic, so that's the catch to this. Now the degree, what you have to look at is, well, how many possible solutions do I have here? Well, for that first one, we have one piece, we have two pieces, so the degree of this is going to be 2. Another way to look at that is how many times I'm going to multiply x through there. So I'm going to multiply x times x at least once, so that's going to be degree of 2. Solutions, how many real solutions we have? Well, let's set each of those pieces equal to 0. When does 2x equal 0? Well, that's when x equals 0. Or we got x plus 5 equals 0. Well, that's going to be when x equals negative 5. So there are our two solutions. The next one down there, we're going to look at how many degrees do we have. Again, we multiply these two x's by each other, which means our degree is going to be 2 again. Now, what you have to look at, is this ever going to change? Is that 2 ever going to change, make it anything different? Well, no. It's a coefficient. The coefficient's never going to change, so that's never going to be able to equal 0. But I can make x plus 1 equals 0, and I can also make 3x minus 7 equals 0. And the way we do that is just x equals negative 1, and from here we'll have to add 7, divide by 3, so x equals 7/3. So it's or x equals negative 1 or x equals 7/3. Now this last one's going to be a little bit trickier to find our degree. So what we need to do is we need to realize, well, first we already have an x squared up in the front, but we're going to multiply that x squared by each of these x's. So you need to see how many that is. Well, it's x squared plus 1 plus 2 plus 3. So it's really going to be x to the 5th is going to be our degree. Now the solutions we have, well, we have 1 here, 1 here, 1 here, and 1 here. So how many actual solutions do we have? We're only going to have 4 real solutions. But it's a degree of 5. That must mean something, right? So let's find our solutions either way. So first one is x squared equals 0. Well, easy peasy. X equals 0, right? Now this one is 2x minus 3 equals 0. So we have plus 3 divide by 2, so x equals 3/2. Next one we do is x plus 7 equals 0. So that means that x equals negative 7. And I'm going to pull this one over here. X minus 9 equals 0. So x equals 9. Again, that only gives us 4 of the solutions. So we have 0, 3/2, negative 7, or 9. Well, the reason there's only 3 solutions is because I can rewrite this equation. I can rewrite it to 0 equals x times 2x minus 3 times x plus 7 times x minus 9. Now that's the same equation, isn't it? Because x times x equals x squared. And then if I do the solving again, I'd break down each of these two here, x equals 0 and x equals 0. It's the same solution, so we don't need to worry about writing it twice. But go back to when we were graphing, that means that it's going to hit and go up at that point. So it's going to actually hit at that 0 and go right back up. So there are really only 4 real solutions, but there's 5 roots to this equation. All right, that's all I'm going to talk about first for these ones. We're going to talk a little bit more about factoring and solving in the next video quick, but go ahead and ask questions if you have them.